This is the IZOD pendulum machine, and we have the scale here, which has 4 different images. This accounts for, first of all, the 2 positions, and also the 3 different weights. You can see over here, there is a large weight. Here on the machine now is the smaller weight, which also has added weights. So this is the medium actually, and so this here is the medium scale with the lower position, which is what we're going to use. It's the 50 pounds foot-pounds units, and so we will be reading the red on this scale. This is the first thing you need to establish. Next, we will look at how this pendulum machine works. We have here the pendulum with the weight, and we need to put in our sample here. Before we do, we need to make sure the safety is on, and so this is the safety latch for extra additional safety. We'll put in this little block. We have the sample, which is steel, and we will put it into the clamp here with the long post down and the notch facing the pendulum, and using a little gauge which helps us to hold it in the exact right position. If you drop it, it will fall in and be hard to take out. So we've placed it in, and with a very, very large Allen key, tighten it into position. Not too tight because it will be hard to pull out. Okay, now we will take off the safety and raise the pendulum. And you will hear a click. Now you will notice that in raising the pendulum, we had it in the number 1 position latch. This is the stop pin to prevent you from pulling the lever. Now we will close the machine and take the stopper pin to the 2nd position, which will allow us to release the lever. Now, when I release the lever, the pendulum will come down and break the sample and come up on the other side. It will use this needle to push.
Okay, I'm ready.
Ready?
Yep.
So now we're ready to release. And here we go.
Can I see?
And now I pull out the release and put on the brake. Now, without moving this little plastic needle, pull the latch back and put it in the 1 position. Opened, and first thing we do is read the reading, which shows us on the red scale about 24. That would be foot-pounds. Okay. So now we take the compass, very handy-dandy compass here, and measure, in this case, let's say we measure it like this. Going from this angle here up at about, I would say 52 degrees. 51, 52 degrees. Okay, now we will show you the calibration. To take out the specimen, okay, here we go. Now we're going to put it in the safety. Raise it back up. Clip, put it in position, and I'm going to release it one more time without a specimen to show how much of an error there is. Because this is potential energy converted to kinetic energy at the 0 and then comes back up to the potential energy, this should go down to 0. Brake on to stop. You can now see that there is an error of about 1 foot-pound. Okay, that's it. What is it? 1 foot-pound.
Okay.
Hi everybody, this is the theory part which we used for the isode impact, and this is the diagram which shows the apparatus which was used in the isode impact test. This is the block which you fit at an angle alpha and at a height A, and it is given in the lab, and W is equal to mg. M is the mass, G is the gravitational pull, and we use this to calculate the potential energy, which is mga. M is the mass, G is the gravitational pull, and A is the height, which is we set it first, like the height of the block at initial point, and like we know the formula for the kinetic energy, which is half mv square. So we know when this block touches the specimen, it would be like potential energy equal to kinetic energy. So we will put both these values, like mg is equal to half mv square, and when we subtract that m with m, and we take v at one side and everything to the other side, we will get something like this: 2ga under root of 2ga. And with this value we can get the value of v, the impact velocity, and by this we can calculate we got the value of energy absorbed when we did the experiment in the lab, and with this we can put in this thing, and we can get the value for the b. Like we got the energy absorbed, we got the m, g, and a, we can get the b, and by b we can get the cos angle beta. Actually we have calculated that, but we can use that in theoretical and practical are the same or different.
Okay, go.
For the absorbed value, we can use the ISO standard to calculate, and then it's divided by the cross section. And unit is kJ divided by million squared, and another standard is ASTM, and it's based on the thickness. So the unit is J divided by millimeter. And here it comes for the error calculation. Error calculation based on theoretical value minus the practical value, and divided by the theoretical value and absolute times 100% to get. And now we're going to verify the initial value A first. For the E absorbed value, we can read it from the equipment directly. So we know the M, we know the gravity, and we know the height, and we know the angle beta. So we can, based on this formula, we can find the initial height first. And then after we get the initial height first, we put into the previous theories, and to find the impact velocity is equal to GA and the square root. So we can, from this, to verify the impact velocity.